Multithreading is a way to make certain aspects of the game run at the same time. So a computer can really only do one thing at a time. There's an instruction. The instruction might be add or subtract, and it can only do that one thing at a time. Modern computers have multiple cores that actually do allow you to do multiple things at a time. But the code is basically just a series of instructions that say add this number, print this to the screen, change the color of the pixel, etc. And so what multithreading, what that refers to, is it allows you to have maybe a physics engine that is simulating objects moving around the world and colliding with each other. It allows you to put that in its own thread, as it's called. So that conceptually it's running on its own, and it doesn't interfere with other code. So it could actually run at the same time as other code if it's put on a different processor core. So that's what multithreading refers to. It's just running code at the same time, at literally the same time.
Today I was trying to multi-thread the client and the server when you're running both of them on your own machine. So this is what happens. It's called a listen server. So what happens if you go through the menu and you say create new game and you select a map. It's going to be running two things on your computer. One is the server and one is the client. When you connect to a game over the internet, it's only running the client on your server. It's only running the client on your computer, and the server is running on some other computer, the one that you're connected to. So what I was trying to do is make the situation when you're running both of them on your computer work basically the same as when the server is remote. So basically, it could run them both simultaneously. So we use two different threads for that. One thread has the client code running, one thread has the server code running.
The reason we spend all this time trying to multi-thread things is because it allows us to utilize the multiple cores that most people have now in their computers. If you just make the game run on a single thread, then only single core of the computer is doing work, and there's a limit in terms of how many gigahertz you can get the processor running at. So essentially, theoretically, if you have two threads running, then you get twice the performance. Now that is the kind of unachievable ideal, but you would have those two cores basically each doing half the work. The problem is that it's very, very tricky to split the work between the different cores, because each step of the calculation often depends on what the previous step calculated. So you need to be very clever about how you parallelize things, and there's all kinds of challenges in terms of splitting the problems up into little chunks that are self-contained and don't depend on each other. And I'm repeating myself now, and that's it. We need like a programming person that could tell us these things.
Programming person, that's what we need.
Well, you know, when you decide to make your own engine, I'm curious why at this point you're not just deciding to make your own operating system.
That's the next step, I think. In fact, we should probably just do our hardware for it too.
So to play Natural Selection 2, you just buy the Unknown Worlds computer, buy the Unknown Worlds operating system, and then buy Natural Selection. It's simple. It's dead simple.
So today Max was trying to run the client and the server on different threads. Normally this is not a common scenario, because usually you have a dedicated server running on a computer somewhere in the server farm. But for when you're playing on a computer on your own, the computer has to run both the server and the client at the same time. Theoretically, it should be very, very simple to run those things in separate threads, because they're designed to be independent. They're designed to run on a completely different computer. Unfortunately, there are some interesting communication problems or something that we can't. We don't really want to spend the time to get to the bottom of, because it's such an unusual case, causing the game it runs in separate threads and it's stable and everything, but it becomes very hitchy and pretty much unplayable. So we're going back to having the server and the client run on the same thread, one after the other. So.
When people say multi-threading is hard, it's really talking about something else. It's like making it work and making it not crash. That's hard. Those aren't, actually, we've never had those problems. Like, I made the rendering system multi-threaded, and that was, I don't know, it took maybe like 3 days, which is actually quite simple. And getting this stuff was pretty simple. The only problem is there are a lot of little details about how Windows schedules the different threads to run, and if you had 1 million cores and every thread could run its own core, then you wouldn't have these problems. But you end up with all these kind of weird performance things that you have to deal with when running inside Windows, and your threads get moved from one core to another, or another process goes and interrupts. interrupts NS2 running or whatever happens. There's just a lot of little mysterious things that Windows does that you have to contend with. An example of a system that works really well with the multi-threading engine right now is the rendering system. We've got another thread that runs in parallel with the game, essentially, and that thread is responsible for submitting information to the graphics card. So it says, draw this polygon, clear the screen, things like that. And that can all happen while other aspects of the game are running. All of the game logic, updating the sound, all kinds of things like that. And we do something similar with physics as well. It can operate pretty much entirely in parallel with the rest of the game. So systems like that work really well. Also, I was showing off the loading screen stuff I was doing. That's all based on multi-threading as well. It can be doing the actual loading part in a separate thread from the thread which is responsible for updating windows, so your window remains responsive and the mouse cursor keeps moving and animating the loading screen and things like that. So sometimes it's a really good model that can work really well. But other times it can be tricky to get multiple threads to cooperate with the kind of performance that you really want.